This is a quick demonstration of how to use the Sun tool in Rhino. We're going to get more in depth next semester, especially with solar sort of gains and analyzing that. And Revit actually does a very good job at this as well, producing some data on solar exposure. But for right now, we're just focused on the basic principle of solar orientation. You can get to the Sun tool in a couple different ways. You can type Sun as the command, simple command, or you can go to the render panel and you can go to the Sun settings under lighting, and you have to make sure that your Sun is turned on. Now if we run the Sun command, or we go to the Sun settings, you can see a couple things pop up. One is these axes, which indicates that north is in the Y direction of the world. By default, that's 90 degrees. I think the file that I gave you is actually at 76 because Austin is about 15 degrees off of the grid of Austin is about 15 degrees off of true north. So you can change that back if you're in another place. It doesn't matter so much. Here is the Sun position given the initial date and time that is set. I'll go back to this in a second. The date and time, changing this is actually going to change the shading of your building. So if you go to let's say rendered mode or even ray traced mode, you can do this in ray traced. It has heavier effects on your GPU though, so you might want to stick to something like rendered. And by the way, you can go into the options and go into each of these views, and you can mess a little bit with the shadows. So under the drop down, there's a shadows drop down, so you can sort of make these shadows grainy or sharper. You can actually change their color as well if you're not seeing these shadows as well as they appear here. Anyways, let's go back to the Sun settings, and you can see my solar position. I can't change it, and that's because it's based on the time and date. So right now it's on June 1st. And I've changed it to Sydney, Australia, and you can see that I'm getting sun from the south. But let's go to somewhere like Brussels. You can see it auto-populates to Brussels there, and you can see the sun coming in from the south. And now if you change let's change the time of day, you can see that the sun rises at about 7 in the morning, and you can see up on the solar the Sun position, you can see it's just north of east, right? And that is indicated by the azimuth. And then the altitude is 17 degrees. That means it's at 7 in the morning, or 6:45 in the morning. It's if you're looking directly at the sun, it's about 17 degrees off the horizon. If we go to midday here, you can see that in the summer, many places in the northern hemisphere at least, the sun is essentially directly facing south, and the altitude is now at a higher 61 degrees. And you can see it set again just north of west. So what I would recommend is just changing your location to where you are in the world. You can go off of this list, and if it's not on there, you can try and choose a place that's close to it. Like if you're in Marrakesh, for instance, you can choose Casablanca. They're close enough. There's not going to be for this sort of study, it's not going to change the sun that much. And you might want to take screen snippings of this, go to something like the summer solstice at noon, and then here you can see we're in the high desert in Casablanca. It's very close to Austin, actually, about 80 degrees directly facing south. So you're going to have a lot of solar exposure on the roof. But if you go to somewhere like December 21st at the same time, you get a lot of shading from the building behind it. But later in the day, you're starting to get some exposure on the west, so you might want to account for that.